Uh, good, mo Good morning and good afternoon and good evening to all the time zones in this meeting. And welcome everyone to the flash talk session of day two. We would be having quite a mixed bag actually for this session. We would be hearing quite a lot about how cosmic rays can help us in understanding solar wind structures and interplanetary magnetic field variations. We'd also get to know about some of the major geomagnetic storm events for the past two cycles, also some statistical understandings of major geomagnetic events in solar cycles. And also we would interestingly have another presentation of how solar effects can have their impact on rainfall over specific areas on our own planet. So before we waste any more time, let's begin the session. So I would like to invite our first speaker. I think Arvind Dhurve is probably not available at the moment. Right. So let's move on to our second speaker for today, who is Ram Das from the Government Auto PG College, Chhindwara in India. And Ram Das would be talking about influence of heliospheric current sheet variability and interplanetary magnetic field on galactic cosmic ray motivation during the rising phase of solar cycle 25. Ram Das, it's all over to you. You can share your screen, please. Hello? Ram Das, can you hear us? I think he was here, right? Okay. All right. Maybe he said he was having some internet issues. Let's see if he sorts that out. We move on to our fourth speaker, I think, because the third one has been retracted. We have Saket Kumar. Is he around? No, I guess. Okay. We have then the next speaker in line, who is Abdeladim El Fakiri. I'm extremely sorry if I have pronounced your name incorrectly. But are you around?
Yes, I'm here. I'm here.
Excellent. Yeah, so we can start with you if that is all right.
Okay.
Great. You can share your screen, and as mentioned, you can speak. If needed, I would give you a quick warning.
I'm trying to share my screen.
Yes, please.
Just moments, please.
Sure, take your time. So Abdeladim is a faculty of science from Muhammad V University, Rabat, and he would be talking about two deep neural network models of thermospheric meridional and zonal winds using FPI Oquamiden measurements.
Browser is share.
You have the
I
share
don't
option.
know how can I share my screen.
You
I'm
have the
trying.
share option at the very middle of the bottom panel. If you move your
Share.
cursor,
I
you see the
find it,
bot. If you
but
move your cursor, can you see the bottom panel with options like participants, chat, react, share?
share. Yes, I see here.
Yes. So
What I will share.
when you click on share, you get a dialog box that opens up with different options, and on the very top, you get the option as entire screen, which says desktop one. Uh, yeah, brilliant.
No,
Excellent. We can see your screen now. You can now go to your presentation.
Okay. First, good morning, everyone. Thank you for the opportunity to present my work.
Sure.
In this presentation, I will present our
Abdulaziz, we
study.
don't, sorry to interrupt you, but we don't see your presentation yet. Can you please go to your presentation first? You don't need to stop share. You can keep it like that. Go,
Stop share.
yeah, then share your screen again and select entire desktop. Select, select entire screen, rather. Yeah, now we can see your slides. Excellent.
Okay.
Perfect. Perfect. Yes, please. Go ahead.
So, in this presentation, I will present our study on two deep neural network models used to estimate thermospheric meridional and zonal wind by using the FPI or Camden measurement. So, the outline of my presentation. First, I will briefly describe the data and the process steps. Then I will present the architecture of our DNN models and training strategy. And finally, I will discuss the seasonal dependence of our DNN models. Data and process. The data used in this study come from Fabric Pero interferometer located at the Okamden Observatory near Marrakesh in Morocco. This instrument observed the 630 nanometer airglow emission, which come from an altitude above 250 kilometers in thermosphere, and by using this emission line, we can estimate the wind velocity. This instrument can observe in four directions: north, south, east, and west. We estimate the meridional wind by the north and south measurement, and the zonal wind by the east and west measurement. Before using the data to create our DNN model, we prepare it as follows. First, we filtered all non-physical wind value. Next, we handled missing data by using the interpolation method. And finally, we represent each night by 25 points between sunset and sunrise. Once the data was prepared, we used it to develop our DNN model. This slide shows our training strategy. So we split our data in two parts. The first part, 2014 and 2015, data for training and validation. So the 19% of each month for training the models and the 10% for validation. The second part of data, 2016, was used for the final test and to evaluate the performance of the model. So this figure presents the deep neural network used in this study. We used 6 features: year, day of year, local time, and geomagnetic and solar indices Kp, DST, F10.7a. And as output, the model generates the wind velocity. In fact, in this study, we didn't create just two models, one for meridional wind and the other for the zonal wind, but we create many models to choose the best one of them. In this table, we show the common hyperparameter used in all DNN models tested. Uh, to compare the performance of our candidate models, we use it a modify Taylor diagram. This diagram summarizes four metrics in one plot: standard deviation, correlation, centered root mean square error, and at the root mean square error. In our case, the Taylor diagram helps us to select the best performing model among several configurations. In this table, we show all the configuration and combination were created and compared in Taylor diagram. On the right, we see the best configuration for creating our model, which we will adopt in the remainder of this study. Seasonal dependence. In this figure, we plotted the meridional wind velocity top and the zonal wind velocity bottom as a function of local time and die of year, generated by our DNN model and by two reference models HWM and TEEGCM. These two figures show the variation of monthly averages of meridional and zonal wind as a function of local time measured during 2016, as well as the monthly average predicted by our model and the other reference model, HWM and TEGCM. We note that our model performs better than the others models and is also able to create the seasonality. In conclusion, this work demonstrates that powerful deep learning models can be built with relatively little data. And thank you for attention. And I'm sorry for my English.
Thank you, Abdulladin. That was a very nice presentation. And don't worry about your
Thank you.
English.
Thank you.
Yeah, we are all here for science. All right, I think we have some time for questions. Are there any questions in the audience at the moment?
Okay, I will try to read it.
If someone has a question, they can raise. Okay, I see a raised hand. Chitradeep, please go ahead, Chitradeep.
Yeah, thank you. Thank you, Abduladim. It was a nice little summary of your work. So I was just curious for this variation of the thermospheric zonal and meridional wind that you have shown. Does it have any correlation with the solar activity? I'm just curious from the perspective that we are talking about sun and heliospheric sciences here. Does it have any causal connection with the activity level, magnetic activity of the sun?
Sorry, can you repeat your question? I can't hear you clearly.
What Chitradeep is, if Chitradeep does not mind, I will rephrase his question.
Sure.
What he is wondering is the modulation that you have talked about in the thermospheric and the meridional and zonal winds. Do they have any correlation with solar cycle, like how the solar activity goes up and comes down? Do you have any idea on that, or do you have any results?
You ask about if there is a relationship between the wind and the solar cycle. That's
Yes.
the question. Yes,
Yes.
there is.
Okay.
And
Can you?
I will try in the next to create another model to
Mhm.
capture the solar cycle and his impact on the wind, thermospheric wind.
Okay. Okay.
Thank you. Thank you.
Thank you. We have another question from Shoykot. Shoykot, you can unmute yourself and ask the question if you want.
Hi, Dr. Shotabu. Thank you for asking. So it's essentially the same question which I think Dr. Chitradeep already asked, uh, which is essentially, if I were to rephrase it, my understanding is that I understand that there is a equation between that relates the thermospheric zonal wind with F10.7 or Kp. I was asking, is it a like what kind of a relationship does it have? As in, is the wind like does it increase or decrease with the change in solar activity? Like, that is what I wanted to understand.
I think, right. I think Abdul probably sort of mentioned that he has that in future work. Abdul, would you like to add something to that?
Sorry, I can't hear you.
Right. What Shoykot wanted to know from you is, again, quite similar to what Chitradeep said. Maybe you can answer to Shoykot in the chat box if that is all right.
Okay,
Yeah? Okay. Thank you. You can stop sharing the screen then.
stop sharing.
Yeah, excellent.
Okay,
I
now.
think we have Ramdas in the audience now. Ramdas, can you hear us? Ramdas? Hello. If not, then we move on to the next speaker. We have Chukwuma Anoru. Do we have him online? No, probably not. Well, so we move on to Geetika Power. Is Geetika around? Apparently not. We go to the last speaker then, Elizabeth Thomas. Elizabeth, are you around?
Yes, sir.
All right, then can we move on to your presentation then?
Yes, sir. Sure.
You can share your screen. Elizabeth is from Mar Thoma College, Tiruvalla, and she would be talking about IOD and solar effects on rainfall over Kerala, a wavelet coherent study. All yours.
Sir, is my screen visible?
Yes, we can see your screen in full screen. Perfect. Please go ahead.
Okay, sir. Thank you. So, good evening, everyone. This is Elizabeth Thomas from Mathama College, Tiruvalla, Kerala. And first of all, let me thank the organizers for giving me an opportunity to present my small work. My work is titled IOD and Solar Effects on Rainfall over Kerala, a wavelet coherent study. Kerala has been receiving rainfall. It's been exhibiting year-to-year strong variability influenced by large-scale climate drivers. The Indian Ocean dipole plays a key role in ocean-atmosphere interactions, while solar activity acts as an external interaction, so external forcing. However, their combined and individual effects across time scales are not well understood. So, this study addresses that gap. In the study, I've used 54 years of data of sunspot number, the IOD index, and rainfall over Kerala. The data have been grouped into 4 seasons: JF, MAM, JJS, and OND. And to analyze the relationships, I've applied wavelet transform coherence to identify the time frequency relationship between rainfall and IOD as well as rainfall with sunspot number, and also partial wavelet transform coherence was applied to isolate the independent effects, specifically rainfall versus IOD, removing the sunspot influence, and also rainfall versus sunspot number, removing the IOD influence. And this approach helps separate the overlapping signals across different time scales. Coming to the result part, as I've told, I performed value transfer coherence between rainfall and IOD for all the 4 seasons. Similarly, uh, between rainfall and SSM. First, coming to the rainfall and IOD results, I have presented just the result corresponding to JF season. Here we observe that compared to all the seasons, JF showed a bit higher coherence part, and but still all the 4 seasons showed significant coherence between IOD and rainfall at around 2 to year scale. And coming to the results of wavelet transfer coherence between rainfall versus sunspot number, the coherence power was less compared to the those of IOD, but still some seasons, during some seasons, SSN showed noticeable kind of correlation at selective periods. Some coherence is actually the localized correlation between the two parameters. Next, partial wavelet transfer coherence was performed similarly for all the 4 seasons. And first, between rainfall and IOD, remember this is exactly the season I've showed before, corresponding the wavelet coherence. Compared to this here, we see there's more of blue color. That is, though the influence is just slightly, that is, even after removing sunspot number, partial wavelet transform coherence could confirm a strong IOD influence in almost all the seasons. But in case of the partial wavelet transfer coherence between rainfall and sunspot number, the power, as expected, the coherence did decrease significantly. But still, in a few seasons, especially the OND, October, November, December, these months, the sunspot signal did persist even after removing the IOD influence, in which indicates an independent contribution. This was performed for all the seasons. Coming to the conclusions, Kerala rainfall variability is significantly influenced by both many other factors, including Indian Ocean dipole and solar activity, though their roles differ in scale and mechanism. Compared to these two parameters, IOD exert a more direct and dominant role as expected. Solar influence persisted independently during the post-monsoon season, even after removing the IOD effects. This indicates that IOD does not fully mediate the solar rainfall relation, but it highlights an independent or maybe some multi-pathway solar influence. Rainfall variability reflects coupled ocean solar forcing across different scales. Thank you.
Thank you very much, Elizabeth, for finishing well in time. We have quite some time for questions, and I already see some questions in the chat box. This was a pretty interesting topic for all of us. So yeah, I think I would encourage the audience to ask the questions. I think there was a question by Aklin Merisha. I'm really sorry if I am not pronouncing your name correctly. Would you mind asking the question yourself by unmuting yourself?
Hello?
Yes,
I'm audible?
Hello.
Yes, we can hear you.
Yeah. So we are, as you are actually signal to noise ratio for the using the solar signals for the our atmospheric data is very high. Yeah. So how can we separate that signals from this separate that signals to find the regional impact on the solar activity?
Ma'am,
You
actually,
understand?
I took.
Yeah. Tell me, ma'am.
Yeah, I almost understood, but actually, I didn't consider this part. I directly took both the parameters from the website and independently performed the work.
Okay, ma'am.
So I didn't consider the other side. Yes, ma'am. Okay.
Yeah, so if we want to find the impact of the solar activity to our atmospheric conditions, what can the measures we can take? What are the quantities we can measure, or just just by the
Ma'am, I didn't.
correlations?
It's not just by correlation, but here actually I considered how rainfall, sun solar activities are affecting. That is, I'm coming from Kerala, so how it is affecting our rainfall over here. And as we all know, it doesn't have a direct influence. It has to have some indirect influence, and one way was via IOD. But a major finding was that it's not completely influencing rainfall via IOD. There is another part, and obviously it has to we have to consider many other parameters also. Right now I can't tell
yeah. Actually,
conclusion.
myself also,
This is just a starting. Yeah.
Yeah, myself also I'm studying this impact of solar activity on atmospheric conditions of the of our planet.
Oh, okay, ma'am.
So
Okay.
that's so for each after each study, the confidence level of that impact is very low, right?
Less.
So that's
Yes.
why I'm asking it.
But
I am
still,
also from
though it's
yeah.
low, that we can't completely deny it. That is another thing. Like if it doesn't have any influence when removed the IOD parameter, the current should have been completely zero. But still, it existed. So I'm sure there is maybe we can't argue that it has a direct influence. Solar activity is having a complete direct influence, but it obviously has an influence. But via maybe some ENSO or IOD, or maybe it affects the internal climate variability. There has to be some relation. That is what we are actually working, like trying to find out.
Okay, ma'am. I'm also from near to Kerala, from Kanyakumari only. Okay, ma'am. Thank you. Thank you
Okay,
for
ma'am.
your.
Okay, thank you,
Okay.
ma'am.
Okay, ma'am. Thank you.
Thank you. Is there any other question for Elizabeth? Probably not.
I had one. Maybe I can reserve that for the discussion if you wish.
Yeah, sure. Let's keep it up then for the discussion
Sure.
section.
Yeah.
Excellent.
Thank you.
Elizabeth, you can stop sharing your screen, and thank you again for a very
Thank you,
nice
sir.
and interesting
Welcome,
talk.
sir.
All right, we move on to our next speaker. We have Chukwuma Anoru. Sorry if I'm pronouncing your name incorrectly.
Yeah, you get it correct. I know.
Oh, okay. Great. Can you share your screen?
Yes.
Chukwuma would be talking about what the May 2024 super geomagnetic storm change in ionospheric irregularities over the American sector.
You can see my screen?
Yes, I can. Can you probably go to full screen mode?
I'm sharing from a PDF. Let me see. Next.
Is that more like a poster? In that case, you
Yeah.
can. All right. Then go ahead.
Because since it is 5 minutes, I decided to just make a post of
Fair
just
enough.
to
No
be on
worries.
time.
Perfect. No worries. Please go ahead.
Okay. So is visible?
Yes, it's visible.
Okay. So my topic is about the May storm. The topic is what the May 2024 super geomagnetic storm changed in the atmospheric irregularities over the American sector. So in this study, we read first about the background atmospheric irregularities. What are these irregularities? They are typical depletion of electron content. So when this happens, they are very detrimental to systems that only rely on radio wave propagation. And also we have some problems in the GNSS. So what we have done, we try to see the day-to-day variability of these irregularities using ionosonde and GPS data. So for the ionosonde data, we picked the parameters of the ionosphere, the H prime F, otherwise known as the visual height, the critical frequency of the F2, that is the F naught F2, and also we try to see the spread F. This spread F are just the irregularities appearing as fuzzy in the ionosonde. So what we have done, we try to see 15 days before the day of this storm, which happened on May 10, and then 15 days after. We want to see the backgrounds, what changed from the backgrounds, ionospheric irregularities to the storm type irregularities. Here in this picture, you see, we use 2 ionosomes and 12 GPS tech data. In the GPS, we try to see the OT index, that is the rates of change in tech. So for the ionosomes, we use 2 stations, one located in the deep latitude within EIA, that is Araguatins in the Brazilian sector, and the other one located slightly beyond EIA coast. EIA is the INO anomaly, that's the equatorial ionization anomaly. So we used the second located in San Jose at deep latitude 22.1, beyond, slightly beyond the EIA coast. So here you see the day-to-day variability here. There, before the storm, you could see that the uplift of the Earth layer rising above 500 kilometers in these two peaks. It was behaving like a sinusoidal, a wave. Rise here, little decrease, rise, decrease, but more interested in the day of the storm. You see here on May 10, there was a very high uplift of the electron content, electron density, rising up to above 1,000 kilometers beyond the field of view of the ionosphere. So we here see out of range, and we see a typical uplift in this tank. When we try to compare the station, ionosphere station beyond the EIA, you see in the days before the storm, we could not record uplifts like we see here in the equatorial region. But when you try to see the date of the storm, they are very comparable. When this happens, we say they are typical equatorial plasma bubble, because this equatorial plasma bubble develops in this equatorial region, and then when you see them simultaneously in the station that is far above EIA, we certainly say it is the plasma bubble. But these two peaks, we see this uplift. We could not see it here in the beyond EIA. So we say this is a background bottom side spread F. So it has no strength. This strength is by the post-sun, during the post-sunset, the solar terminator, during solar terminator, there is an uplift, otherwise of the electric field, otherwise known as the pre-reversal enhancement. So this is typical culprit for these spreads to occur. So here, for the storm time, there is a very strong pre-reversal enhancement that made the EPB, that is the plasma bubble, to occur. So here also in the F0 F2, we try to see what happened in the F0 F2. F0 F2 is just the proxy for the electron density. So here we are more interested to see on the day of the storm. If you compare days before the storm, there is F0 F2 rising above 18 megahertz, which means in the bottom side F region, there is still electron density. But here, when you pay attention in the day of the storm, you see a depletion before it went to out of range of the ionosphere field of view. So here, it certainly means there is a typical EIA, that is ionization anomaly. Electron content, electron density try to move away from the bottom side up to the higher altitude. So here, when you compare, you see here, there is a very high peak of electron here, moving above 18 megahertz, which means a typical modification of the EIA. So we try to see in the spread F, this is the spread F occurrence, the day-to-day variability of the spread F. Here you see the range spread F and the frequency spread F. So the range spread F, you see here the days before the storm, there is occurrence of a spread F here. But when you compare for the region that is within the EIA, but the region out of beyond EIA, you see when you compare days before the storm, there is no occurrence of spread F. It means these here are bottom side spread F, but day of the storm, there is a typical plasma bubble, which you see simultaneously from the region that is within the equatorial and the region that is beyond, that is the higher altitude. So we try to compare this aerosol with the GPS tech data using 12 stations. We focus on the American sector station located within the east and those located within the west. We also try to,
if you can wrap up a little quickly.
Yeah, okay. So these are the stations for the GPS. You see here, when you compare the day of the storm, there is a typical ROTI index that is rising up to above 1 tech units per minute. This is in support of the ionosphere, so it is both correspondent. That's the GPS and the ionosphere also recorded this EPP occurrence. So in conclusion, we said that the findings based on this analysis shows that the EPB with net cell before the day of the storm are typical PROT that is as of low as possible, and also a contribution of the dynamo of the electric field. For the day of the storm, there is a contribution of the pre-reversal enhancement, strong pre-reversal enhancement with that of the Bond's penetration electric field. So thank you.
Thank you, Chief. That was a very interesting analysis and work. Do we have questions? One quick question, maybe? In the audience, do I see any raised hands? Not yet. Well, if not, then we can always avert it for the discussion section. Oh, we have one question from Chitradik. Chitradik, would you like to ask it yourself?
Yeah, thanks. Just a quick question. You mentioned dynamo, and I'm just curious to know which dynamo action are you referring to in your work?
The electric field dynamo.
I mean, the spatial
The
scale. I mean, is it within it's the solar dynamo or the different from that, something else? And what is the spatial region? Is it the solar dynamo or something else from that? I believe it's different from solar dynamo.
This is just the neutral winds and the interaction of the ionosphere dynamics.
So it's taking place in the ionosphere of the Earth?
Yeah. Next.
Okay.
Oh, great. Yeah. Great. Yeah. Thank you.
Yeah, that was a good clarification. Thanks, Chitradeep, and thank you, Chukwama, for the very nice presentation. You can unshare your screen now.
Okay.
Thank you. Do we have Ramdas? Yes, we do. Ramdas, can you hear us? रामदास आप सुन सकते हो हमें? हेलो?
हेलो।
हाँ, रामदास, आप अपना स्क्रीन शेयर कर सकते हैं.
Yes, sir.
You can share your screen. Yes, sure. But I do see a lot of activity going on in the chat section, which is really great. I see there are so many questions coming up, and I also see the speakers responding to the questions. We can always go back to the discussions in the chat box in the discussion section that we have kept reserved. Hopefully, if we have some time at the end.
सर स्क्रीन शेयर नहीं हो रहा है, पता नहीं नेटवर्क इशू
आप
है।
नीचे देखिए, नीचे स्क्रीन शेयर वाला ऑप्शन दिख रहा है आपको? जब
यस
आप
सर।
जूम का विंडो खोल के आप अपना कर्सर जब हिलाएंगे तो नीचे आपको एक पैनल दिखेगा जहाँ पे पार्टिसिपेंट, चैट, रिएक्ट, शेयर, ये सब ऑप्शंस दिखेगा.
लैपटॉप से कनेक्ट कर रहा हूँ सर, थोड़ा देर इशू है।
नीचे वाला पैनल दिख रहा है आपको?
क्या सर?
नीचे वाला जो पैनल है जूम में, आपको वो दिख रहा है? पार्टिसिपेंट्स, चैट, रिएक्ट, शेयर.
यस सर।
हाँ, तो वहां पे शेयर वाला ऑप्शन पे आप क्लिक कीजिए.
ओके ओके।
तो वहां पे आप जो एंटायर स्क्रीन वाला जो ऊपर वाला जो ऑप्शन है उसी को सिलेक्ट कीजिए, फिर शेयर में क्लिक कीजिए.
So participate.
To the organizers, do we have Ramdas's presentation with us?
Yes sir.
नहीं, आपको नहीं. आप शेयर कीजिए.
No, we do not have the presentation with us.
Okay. Perfect. I think he is. Yeah. हाँ अभी हम आपका ब्राउजर देख सकते हैं, इंटरनेट वाला। आप अपना स्क्रीन को चेंज करके जहाँ पे अपना स्लाइड्स है उस स्क्रीन पे जाइए।
यस सर।
हम्म, हाँ हाँ, पीपीटी ओपन कीजिए।
शेयर नहीं हो रहे हो, पता
नहीं नहीं, आपका स्क्रीन हम देख सकते हैं, शेयर हो चुका है। आप बस प्रेजेंटेशन ओपन कीजिए डबल क्लिक करके।
ओके सर, ओके ओके।
हाँ, शेयर हो चुका है।
जी मेरा
आपका पीपीटी अभी तक ओपन नहीं है, आप उसको ओपन कीजिए। हाँ हाँ, अभी हम देख सकते हैं। अभी आप इसको फुल स्क्रीन में क्लिक कीजिए। ऊपर स्लाइड शो वाला
सर
ऑप्शन दिख रहा है आपको? ऊपर स्लाइड शो दिख रहा है आपको?
लाइट तो
ऊपर एक ऑप्शन है आपके स्क्रीन में, देख ये जो फाइल होम। ठीक है, आप नहीं तो आप ऐसे ही प्रेजेंट कीजिए, कोई बात नहीं, आप ऐसे ही प्रेजेंट कीजिए।
नीचे जो माइनस के बाजू में एक आइकॉन है उसको क्लिक कर दीजिए।
हाँ, उसके
माइनस
उसके
माइनस
लेफ्ट,
दिख रहा है आपको?
उसके बाएं तरफ, उसके
निगेटिव।
बाएं तरफ, उसके बाएं,
हाँ,
हाँ
बस
हाँ
उसके
हाँ।
बाजू में। नहीं,
नहीं नहीं नहीं
उसके
नहीं, आप उसके बाएं तरफ एक छोटा सा स्क्रीन जैसा दिख रहा है, एक स्क्वायर बॉक्स, ये जो माइनस साइन है, माइनस,
यस
ये
यस सर।
माइनस साइन के लेफ्ट में। हाँ, इसको
हाँ
क्लिक
वही,
कीजिए, उसको क्लिक।
उसके बाजू में।
नहीं नहीं, वो नहीं, वो नहीं। आप
ओके,
बैक,
सबसे कॉर्नर वाला अभी
वो
आपको
पीपीटी
दिख रहा है,
टाइम
सबसे
में तो
कॉर्नर में जो है।
एकदम कॉर्नर में जो है, राइट में, हाँ
हाँ,
ये वाला, बिल्कुल, बहुत बढ़िया।
यस सर, इसमें टाइम प्रिंट तो है सर, चैट हो।
हाँ चलिए शुरू कीजिए। ऑल राइट।
Good morning and good afternoon. Today I am going to present my research on implication of heliospheric current sheet, variability and interpolating magnetic field on the galactic cosmic ray, modulation of during the rise phase of solar cycle 25. First, I will brief the induced basic concept of discussion methodology, result and conclusion. Introduction is a galactic cosmic ray or galactic cosmic ray are high energy charged particles that the origin outside our solar system. When there's the particle enter the heliospheric, they are the intensity are affected by the solar activity. The sun follows the 11-year cycle known as the solar cycle 25. During its rise phase, solar activity increase, which significant effect of the cosmic ray modulation. Heliospheric current, heliospheric concept. The heliospheric is a large region surrounding the sun filled with the solar wind and magnetic field. It it acts like the productive the solar system from the income cosmic ray. This region play the major role in controlling the cosmic ray travel. Heliospheric current sheet. The heliospheric current uh, sheet is a large way structure in heliospheric where the sun magnetic polarity change. As solar activity increase, this sheet is become more distort or way. This effect of path cosmic ray and contributed they are the modulation. Interplanetary magnetic field. If the interplanetary magnetic field is carried by the solar wind from throughout the solar heliospheric. It is has the spheric structure known as this magnetic field, directly influencing the momentum of and intensity of cosmic ray. Objective and the main objective this study is analyze the effect of the heliospheric current sheet variability, the steady inflation of intergalactic magnetic field, understood the cosmic ray modulation during the rise phase of solar cycle 25. It is the methodology. This study way used to observational data, neutral monitoring as space-based the student. We analyze the parameters such as cosmic ray intensity, electromagnetic field, heliospheric current sheet, tilt angle, statistical method where you find the correlation between this the parameter. Our result is so that cosmic ray intensity decrease with inter electromagnetic field stress increase. Increase with weakness the heliospheric current sheet lead the strong modulation the cosmic ray. This indicates the strong relationship between the heliospheric condition and cosmic ray behavior. It is a conclusion both the heliospheric current sheet and interplanetary magnetic field play the significant role the cosmic ray modulation during the rising phase of solar cycle 25 solar activity strength implications that affect this to the summarize cosmic ray the modulation by solar activity heliospheric current sheet and interplanetary magnetic field are key controlling the factor they are effective or more promoted during the solar cycle 25. Thank you for your
थैंक यू रामदास बहुत बहुत धन्यवाद रामदास
यस सर फर्स्ट
एक
टाइम ही ट्राई किया सर मैंने
कोई बात नहीं कोई बात नहीं बस एक छोटा सा सजेशन मेरी तरफ से आपका जो है स्लाइड्स पहले खत्म हो चुका था जब तक आप बोल रहे थे तो आप नेक्स्ट टाइम जब आप ट्राई करेंगे तो ये
सर उसमें टाइम वो सेट हो गया कहीं से
अच्छा 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 कोई बात नहीं आप फिर से जब करेंगे तो बेहतर और अच्छा होगा डू यू
यस
हैव एनी
सर
क्वेश्चंस फॉर रामदास
यस सर
I think this is a very interesting topic about current sheet variability with cosmic rays. Do we have any questions in the chat? Well, Chitradeep has a question. Yes. Chitradeep, please ask
Maybe
your
I
question.
can again reserve this for the discussion. By the way, रामदास धन्यवाद ये टॉक अच्छा था मैं बाद में आपको क्वेश्चन पूछूंगा थैंक यू
थैंक यू सर
All right. Maybe we go directly into the discussion. We don't have time yet. We can maybe use 5 minutes if that is okay with the organizing committee.
Sure.
We
Yeah.
have some time. If we need to extend the discussion, we can, subject
Okay.
to the condition that we have enough matter for discussing. Yeah.
Sure. रामदास आप स्क्रीन शेयरिंग बंद कर सकते हैं अभी
यस सर ओके
ओके
थैंक यू सर
कोई बात नहीं आपको धन्यवाद let's quickly go into the discussion section. I saw quite a lot of discussions that was going on in the chat section, which is, as I said, extremely enthusiastic. I see a lot of comments from Elizabeth about her presentation and obviously from Abdiladim. Does anyone want to make any further comments as follow-up of whatever has been said and sung in the chat section? If not, then I would like to ask one question to Ramdas, which would be about Ramdas said that he finds correlation with current sheet variability with the rising phase of the solar cycle. I'm just curious what happens in the decaying phase. तो रामदास आपके लिए मेरा ये क्वेश्चन है कि आपने कहा कि सोलर साइकिल का राइजिंग फेज में आपको कोई कोरिलेशन दिखा है करंट शीट की वेरिएबिलिटी के साथ साथ कॉस्मिक रे का मॉड्यूलेशन, तो क्या आप अभी ये भी देख रहे हैं कि डिकेइंग फेज में कैसा होता है या मिनिमम में कैसा होता है, या आपके पास इसका कोई ऑलरेडी एनालिसिस है? हम आप शायद म्यूटेड है, हम आपको सुन नहीं सकते। If there is some technical issue from his end, then we would postpone that question. There, I had another for Chukwuma about the May 2024 superstorm. And I was wondering that the source region for that particular eruption was pretty complicated, and it was more towards the southern hemisphere. And you had some results which I don't really recollect about a hemispheric preference in your results. Would you like to comment on that? I don't know if I phrased my question very clearly. Is Chikwuma now? Yeah, I do see him. Well, maybe there's some problem. If not, are there any other questions from anyone else? If they want to put up any other topic to discuss? No, then all right. I would then take this opportunity to once again thank all the speakers for giving very interesting presentations. And I wish all of you all the best for your future presentations to come up. I should tell you that I know that flash presentations are a bit tricky because you need to learn the skill of highlighting the crucial or the key aspects of your work in a very short time. But I'm pretty sure this would help you in your future presentations as well. So thank you so much for attending the session and for presenting and sharing your work with us. And we look forward to many more interactions in the future. Thank you.
Thank you, Shatabda, as well.